Okay, Assalamualaikum and good morning, everyone.
Good morning, sir.
Okay, so today we will learn a new chapter. Okay, we will use COMSOL multiphysics. So you can now uninstall MATLAB and install COMSOL in your laptop. And before that, I want to brief to you guys about your project for this semester. Okay, so in this project, you guys will be able to develop an understanding of human anatomy and physiology related to disease or engineering applications as part of lifelong learning. Okay, so lifelong learning meaning that you apply everything that you learn in mechanical engineering towards other things that are outside of mechanical engineering. For example, in human or biomedical engineering. And then you also will able to define a problem based on human biomechanics using mechanical engineering knowledge, and then solve the problem using finite element analysis tool and analyze the results using the same software. Okay, so this semester the project is 35%, and what I want you to do is only a presentation slides, okay, that contains all the um, uh, points or information or description related to the project, okay, including the citation and reference. And for the presentation, I think we will do it on week. Um, I think the best week that we can do is maybe study week Monday, if that's okay to everyone, because I think week 14 will be quite hectic this semester. So we do the presentation for project Monday study week. Okay, if uh, if there is nothing on the day, okay, like test or etc. So there will be 5 tasks, and each of the tasks will contribute to 20%. 20% of the overall 35% marks. Okay, so you already have groups. Okay, so each group is already given title. Okay, and you guys can refer to the link that I gave previously. And then for task one, you guys need to read and write a little bit um, related to the project or the title given to you. So you can write some introduction related to the anatomy or physiology of the organs involved, or the device that you guys will study, and describe one disease or a common disease and treatment that that is common, okay, used in each of the title. And then you need to define one simple problem that you can study using finite element method. So for example, project. Okay, so we have 6 group. So for example, group number 1, you guys will be doing functional electrical stimulation in leg muscle. So in this thing, basically it's a device that helps muscle that usually paralyzed muscle to contract. Okay, so that the paralyzed person can still move. Okay, so it's like applying an electrical signal to the muscle and causing the muscle to contract. So maybe in this topic, one simple problem that you can study is maybe the electrode size, the different electrode size. What happen if we use one small electrode and the other electrode is bigger electrode? What will happen? Like how much current will be delivered to the muscle. So maybe you can study that problem, or the distance between two electrodes, or maybe you can study muscle in different size of person. Maybe fat person, maybe they have a layer of fat that maybe hinder the propagation of electrical signal to the muscle, and compare it with a skinny person. Okay, so there are a lot of problems that you can study using finite element, but choose only one simple problem, and maybe try to relate that problem with um, some common findings or from a papers and so on. So group number 2, you guys will be doing airflow in trachea that is blocked. So maybe you can study a simple problem like the size of blockage. Okay, so maybe you draw a tube. A tube represent a trachea, and then you draw a blockage in that tube. So you can study different size of blockage, or maybe um, different shape of blockage, maybe constriction, or maybe um, anything. Okay? And then group number 3, you guys will be doing blood flow in aneurysm. So aneurysm is when the blood vessel, usually in the brain, part of the blood vessel becomes like benjol, okay? Like it forms a balloon, okay? So over time, this balloon can burst and causing a stroke in patients lah. So maybe for this group, maybe you guys can study the different size of aneurysm, or maybe different type of aneurysm, like maybe if there are 2 balloon or 3 balloons and so on. And then group number 4, you guys will be study about the impact on spinal cord. So maybe this one, this is rather simple. So you need to draw a spinal cord and apply an impact force. So maybe you can mimic an impact from a motorcycle crash, for example. So what happens if there's a crash? Maybe you can study different location of impact, maybe from top of the spinal cord, maybe from the side of spinal cord. So what happened to the spinal cord? Maybe it will bend, or maybe the different location of impact maybe give different kinds of impact to the spinal cord. And then group number 5, we'll study about simulation of punching effect during boxing. So maybe you can draw a head, and then you apply a different force to mimic a punching. Okay, so maybe a force, a small force represent a small impact, maybe a bigger force to represent a bigger impact. Or maybe you can study different location of impact, maybe on top of the head, maybe on the chin, and so on. Okay. And then lastly, group number 6, we'll study the retinal neuroprosthesis design. So this one is you can study the different electrode design in retinal prosthesis. So this one you need to Google what is neuroprosthesis. Basically, it's a prosthesis that replace our retina. So it's like an array of electrodes that will be put inside our eyes, and when there's a light coming into our eyes, this electrode will detect the light and form an image to our brain. Okay, so maybe you can study different shapes of the electrodes, or different arrangement of electrodes, and see how this arrangement or size affect the electrical signals received by the implant. Okay, so what you need to do first is read a little bit about the title and come up with one simple problem that you can study using finite element method. So example in this slide, I give example related to tooth filling simulation. Okay, so what I will do is I will explain the physiology and anatomy of the tooth and explain disease that requires dental filling. Okay, so maybe cavities is one of the disease. And then I can study the type of dental filling, like using metal, using ceramic, and then the advantages and disadvantages of each of the dental filling. And then maybe one of the problem that I can study is different types of material, okay, for the dental filling. Maybe I can use metal, maybe titanium or cobalt chromium, and see what is the effect of different metal uh, to use as a dental filling. And then I can use finite element method. And then task number 2, you need to sketch your ideas, okay? Maybe put in figures, okay, or in drawings by hand. So here I take a picture of a tooth, and then I put, uh, I take a picture with tooth cavity, and then maybe I can take this and then represent it in a simple geometry. So maybe the blue part here, I represent it as a filling, and then the white part as the gigi, as a tooth. So maybe the blue part I can use different filling material, titanium, cobalt chromium, and then the tooth I can just use common bone material. So what kind of simulation that I can do? Maybe apply a force on top of the teeth uh, to represent chewing process, okay, proses makan. And then what happened to the teeth? Maybe the titanium maybe bengkok ke, and so on. And then task number 3, we will set the problems into finite element method software. So you draw a geometry. So ideally we draw a simple geometry. So the teeth just now, the tooth, maybe we can draw a box to represent the tooth, and then maybe there's a hole in the middle, and then we fill the hole with a different materials, maybe titanium or cobalt chromium, and then we use a suitable physics and set material properties, and then apply boundary condition, use suitable meshing, and choose suitable study type, maybe static or dynamics. And then lastly, we can analyze the results. So for analysis, it's open-ended, meaning that you can analyze anything that you think will give an understanding about your problem, okay? Maybe solve your problem or give insights, okay? So here, in this case, maybe I study for the deformation of the teeth, and then the stress, and so on. And then I can determine which material is the best to be used as a dental filling. Maybe compare with literature. And then usually extra marks will be given if you do a little bit of creativity on your analysis. Maybe you draw something, you plot something that actually give more insights, okay, or more understanding about your problems. And then lastly, you guys will have a presentation. So you will present your findings, and this is only to see how you understand about your presentation, okay, and not to condemn about your work. And I will ask questions related to your work, okay, like why you choose the geometry, why these conditions, and so on. And from the results, what do you understand, and maybe some common knowledge related to the title. So for the Q&A, it's individual marks. So if you let your friend help you, so nobody gets the mark, okay? So each member will have a question. So each member has already an allocation for the Q&A marks. So if you help your friend, so you don't get the extra marks, and your friends will not get the marks as well. Okay, so if you have any problem, any question related to the project, just let me know. I will upload this in Kalam after the class, okay? Okay, so any question before we start the lecture?
So far, no, sir.
Okay, so for today we will start a new topic, and we will use COMSOL multiphysics, okay? Okay, so in this lecture we are going to look at a PDE based model. Okay, so in previous lectures when we use MATLAB, we actually solve for ODE. So ODE, basically what I said in previous lecture is that it's a equation that has derivative on with respect to one single variable. So usually it's with respect to time, okay? But in PDE, we have equation, but it is with respect to more than one variable, either time and with time and also space, okay? So time and space. So the space here represent the geometry. So if you do FYP related to finite element, maybe if you study for fluid flow in a tube, for example, so the tube is actually the space that you want to study or to solve the model. And for example, if you study for finite element analysis of a beam, for example, so the beam itself is a space that you study, okay? So it's not the space like the surrounding space, it's the space. Space is the geometry that you want to study. So in this lecture, all of you will be able to understand the application of PDE in modeling a biomechanic system. Also understand how to solve PDE using finite element method. And we will solve and analyze various PDE model using COMSOL multiphysics. Okay, so a little bit introduction about finite element method. So finite element method is actually a numerical method that usually is commonly used to solve PDE. So PDE is difficult to solve by hand. So we will use numerical method. So one of the method is finite element method. And the advantages of finite element method is that um, it doesn't need the geometry to be simple. It can be used in any types of geometry. Okay, so for example here, figure A and B represent your lungs. Okay, so you can mesh the lung, and finite element method can mesh this lung and solve the PDE on this lung. So it doesn't matter if the lung is complex or simple, as long as you can mesh it, then uh, this lung can be used to analyze any PDE model. And on the right here is an example of your iota. So you can study fluid flow in this iota because if you use finite element method, it can mesh this easily, even though the shape is kind of complex. So this is very useful in biomedical application because in our body, usually the organs or the tissue has a very complicated structure. So it's hard if we use um, the usual numerical method, for example, like finite difference method. So an advantages of FEM is that you can handle irregular domains, okay, or geometry and inhomogeneous media. And it is more memory efficient than finite difference method. But however, you need to mesh the geometry. So the problem comes with the mesh. If your geometry is complicated, then more mesh is needed. So when more mesh is needed, then more computer power also needed. Okay. So let's look at the general steps. to study something using finite element method, but we focus on COMSOL. So firstly, you need to determine the model dimension. So model dimension here means that um, your problem is in what dimension? Is it a 2D problem? So 2D only has X and Y direction, or is it a 3D problems? So is it involve another direction like Z direction? So you need to choose what kind of dimension that you want to study. And then number two, we need to determine what kind of physics or what we need to study. Like if you want to study fluid flow, then we choose fluid dynamics as the physics. So if you study for electrical simulation, then we choose electrical type physics. And if your study is related to solid mechanics, then we choose physics related to solid mechanics, and so on. So there are a lot of physics in finite element method that can be solved in finite element method software. We can solve heat transfer, fluid dynamics, solid mechanics. So maybe in your finite element method class 3562, 3563, you are only exposed with using finite element method to solve for solid mechanics problem. But actually, it can be used in any of the problems like heat transfer, fluid dynamics, and so on. And then number three, we need to determine what kind of study that we want, either static study or dynamics. So static is basically a study at one particular time point, while dynamics, you study the simulation when the time is changing. Okay, so static study is usually used in a simple project like your project, because it's easier to solve and doesn't require a lot of computer power, while dynamic study is usually used maybe in a bigger project like FYP and so on. And then we need to develop our geometry. After we determine all this, then we develop our geometry. So we can develop the geometry maybe using a simple shapes like square or a cube, a sphere, maybe a sphere to represent the head, maybe a tube, a cylinder to represent a trachea or a blood vessels. And we can also use a complicated geometry that mimic the actual organ in our body, but that one will involve another things, okay, like image processing and so on. And then number five, we need to determine the material properties, the material parameters, sorry, the material parameters and variables of the things that we want to study. So we need to determine the material for the blood. Is it a Newtonian fluid or non-Newtonian fluid? And then we need to also we need to determine the material of the maybe the skull, for example, or the spinal cord. What is the Young modulus, Poisson ratio, or we can determine the conductivity of a muscle or conductivity of the electrode in the retina, for example. And then after that, we can set boundary conditions in our geometry, in our model, like which part is fixed, is going to be fixed, and which part we need to apply forces, for example. And then after that, we mesh the geometry. So we mesh the geometry. So usually in software, it will be automatically meshed. Uh, Unless if the geometry is complex, then we need to mesh manually. And then we can solve the model. And then after it is solved, then we can do the analysis of the results. So the the steps here are the common steps for finite element simulation. So maybe in your test later, when you want to simulate the problem in the test, so please try to follow these steps. Maybe sometimes you start with geometry first and then mesh first, so you miss the steps in between. So you will confused. You will get confused about when answering the test question. So if you have COMSOL, you can open your COMSOL and try to explore. So in COMSOL, first we need to determine the model dimension. So in COMSOL, there are 6 kind of model dimension. So usually we use 3D, 2D, and 1D. So 0D is basically we go back to ODE. So we use 3D, 2D, and 1D. So 3D is a 3D space. So 2D is a X and Y. So 1D is on the X direction. So we have also axis symmetry. So maybe tomorrow we will see simulation related to axis symmetric. And what is axis symmetry about? So it's basically a geometry that revolves around an axis. But tomorrow we will see an example related to axis symmetry. And then after that, we can choose physics in COMSOL. So there are a lot of physics. So if you use get into PC punya COMSOL, so you can have all of this physics. But if you use the licensed one, maybe certain physics je ada. So in our lecture, we are going to use these 4 only. So mathematics, ACDC represent electrical simulation, structural mechanics for simulation related to solid mechanics, and fluid flow simulation related to fluid. Okay. And then we can choose the study type. So we have stationary and time dependent. And there are other studies, but it's specific for other kinds of study. Usually we will use stationary and time dependent. So stationary is for static cases and time dependent for dynamics. Then after you start the simulation, there are this layout in COMSOL. So you can start with drawing the geometry. So in the geometry section, it's something similar to SolidWorks, but more difficult to use, okay, in COMSOL. So you can draw any kinds of shapes in this in COMSOL. So we have block, cone, cylinder, and some other geometry in the more primitives. So later maybe you can explore the software. And also you can import geometry from CAD software like SolidWorks, AutoCAD. And then we can set the material properties or material parameters. We can write this in the parameter. Maybe for blood, we need viscosity and density. For bone, we need Young modulus and Poisson ratio. And some other things, maybe we need different parameters. And in COMSOL, it has library that contains all the material values for different types of things like blood, bone, and so on. But usually for me, I will define the material parameters manually instead of using the library. Sometimes the library is it's taken from something that is very common, okay, but not taken from maybe journal paper and so on. And then after that, we can define boundary conditions. So in ODE, we have initial conditions. But in PDE, we have both initial conditions. So initial condition is the condition for time 0. And then we have boundary conditions. So boundary conditions are the value of the variable that you want to solve at a given boundary of the geometry or of the space. So example here, let's say you want to study heat transfer in a bar. So we have 2 boundaries here. One end here is one boundary, and the other end is another boundary. So maybe the top end, the top part of the bar and the bottom part of the bar also can be a boundary. So you can apply boundary conditions on top or at the bottom of the bar. So it depends on what kind of boundary that you want to set. But to study heat transfer, usually we set one end has zero temperature, while the other end, we usually heat the other end. Maybe we apply a temperature at the other end. So here in this case, this example here applies a freezing temperature at one end, and you want to see whether the bar will be cold over time. And then this is another example of boundary conditions. So if you want to study fluid flow, so you apply an inlet velocity or inlet pressure or whatever that can cause fluid to flow inside this tube. And then we apply the outlet with maybe velocity as well or pressure to make sure that the fluid flows from the inlet to the outlet. And then the top and the bottom part of the tube, usually we apply a condition known as wall, okay, or no slip boundary conditions. Later, in lecture related to fluid flow, we will see more on this. And then we can do the mesh after we set all the physics and the boundary condition. Usually we will use automatic mesh because it's easier. The software will mesh it automatically. And we only change the size of the mesh. So here in COMSOL, we can change the size of mesh from normal. So normal is the normal size. So we can increase the size of the mesh. Maybe we use a bigger size. So we name it as coarse. Or we can use a smaller mesh size. We call it fine size. So you need to be cautious if you use smaller mesh size or finer size, then the software will require more RAM to solve the simulations. So we will use normal, and when it use more RAM, then your computer may be akan stuck lah, okay, akan jam. And then we can solve the simulations after we identify all the settings are correct. And this will take some time depending on your simulation size, such as the mesh, whether your mesh is small or big, and then the geometry, and also the complexity of the problems. And then we can analyze the results by plotting suitable graphs. And there are many types of plots that you can explore. And also, I will show you an example of plots, but not all, but you can explore later. Okay, so that's it for today. So what I want you to do before we go into exploring COMSOL tomorrow, maybe you can explore the assignment. I think I already put it in Kalam. So assignment 3 is basically a tutorial on COMSOL multiphysics. So it is related to electrical signals in a heart, which we will also learn tomorrow. So I want you to try to explore this tutorial first and try to familiarize yourself with COMSOL, okay? So in this tutorial, steps are given already. So you just follow the instruction one by one, okay, until the end. So basically the instruction starts from drawing the geometry until analyzing the results. So try to explore and familiarize yourself with COMSOL multiphysics. Okay, so any question before we end this lecture? So if there's no question, then tomorrow we will meet again at the same time. Thank you and Assalamualaikum. Goodbye.
Yes, sir.